For this problem, the falling hammerhead has a net downward force equal to F, which is the weight minus little f, and the weight is 200 kilograms times 9.8 meters per second squared minus 60 newtons, which is about 1900 newtons. Keep in mind this is downward force. So the total work then, total downward work, is going to equal the 1900 newtons times 3 meters, which is 5700 joules. There is a theorem called the work energy theorem. And the work energy theorem states that the work done by a system is the equivalent to the change in kinetic energy of that system. And since the hammerhead starts at rest, we can say that the total work in this case, 5700 joules, is equal to kinetic energy final minus kinetic energy initial, but initial kinetic energy is 0. So this is equal to 5700 joules is equal to 1/2 m v final squared, which means that v final squared is equal to 2 times 5700 joules divided by the mass, which is 200 kilograms, which is about 7.55 meters per second. So this is the speed at which the hammerhead just hits the I-beam. For part B, the total downward force is now different, because in this case F is W minus the normal force minus the force of friction, which means that the work is going to be W minus F sub n minus F times column S2. S2 is now the distance that the I-beam travels while it's in contact with the hammerhead. And this also is going to equal to K initial subtracted from K final, but now for the hammerhead I-beam system. And in this case we know that it stops, so that is 0. And now we can say, okay, well, work weight minus the normal force minus the friction force is the same as minus the initial kinetic energy over S. So the normal force is going to equal the weight plus the kinetic energy over S minus the friction force. And we know that the weight is 200 kilograms times 9.8 meters per second squared, plus the initial kinetic energy is the total work that it started with, and the distance it moves down is 7.4 centimeters, or 0.074 meters, minus 60 newtons, which is the friction force, and this gives us about